Hello everyone, myself Vinay Kumaram. I'm pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So coming to the exercises which is there in this particular gravitation chapter, in that, coming to the sixth question, here you have three different questions in this particular sixth question. Here simply they are asking what happens to the force if these following conditions are given. So now coming to the first case, here they have asked mass of one object is doubled. So in first condition it is given that mass of one object is doubled. So if mass of one object is doubled, then what happens to the gravitational force between those two objects? So force F is equal to universal gravitational constant G multiplied with mass m1 and m2. So if these two are the two objects, then m1 is the mass of first object and m2 is the mass of second object, divided by distance d square. So whatever distance is there between these two objects, so that you should actually consider the center of these objects. So that can be the distance between these two objects. So according to universal law of gravitation, F is equal to g m1 m2 divided by d square. So if this is the initial force, that is F1, then the final force F2 when the mass of one object is doubled. So for example, if mass of first object is doubled, so that means you have to multiply this particular m1 with 2, because you are increasing the mass of one object by 2 times. So that means you are doubling the mass of one particular object. So that means here G will be equal to 2 into m1 into m2 divided by d square. So the new force will be equal to, so F2 is equal to 2 into G into m1 into m2. So here you have increased the mass of one particular object, that is m1. Here you have just doubled the mass of one particular object, so that's why I am multiplying 2 where you are considering the new force. So 2 into G into m1 into m2 divided by d square. So this G into m1 into m2 divided by d square can be considered as F1. This entire term is F1. So you can directly write this as F1 and 2 is there. So 2 into F1. So that means here F2, the new force will be increased by 2 times. So in first case, force will be increased by 2 times. So force will be increased by 2 times. So whenever mass of one object is doubled, then force will also be doubled, or force will be increased by 2 times. So this is first question. So in the same sixth question, if you come to the second one, here they are asking the distance between the object is doubled and tripled. So that means here new distance is equal to, so here new distance is equal to 2 times the distance, and the same new distance, the other new distance is equal to 3 times the initial distance. Because here they are asking if the distance is doubled or if the distance is tripled, what will be the effect on the force, on the gravitational force. So here F1 if you are considering, so that is the old force if we are considering, then that is equal to G m1 m2 divided by d square. Now you have to consider F2. So F2 is the force when distance, the new distance is equal to, so the new distance when it is equal to 2 times the original distance, the initial distance, then new force will come into the picture, that is F2. So we'll call that as F2. So that F2 is equal to G m1 m2. So I have taken small m. So m1 m2 divided by d square is there. But here you are taking the new distance as 2d. So 2d whole square will be there. Now if you calculate this, this will be equal to G m1 m2 divided by 2 2s are 4, d square will be there. So now G m1 m2 into d square, you can call this as F1. So F2 is equal to F1 divided by 4 will be there. So that means whenever distance is doubled, so here whenever distance is doubled, force is reduced by 4 times. So force is reduced by 4 times, because here you can clearly see the new force F2 is equal to F1 divided by 4. So that means 4 times reduction is happening in the new force. Now if the same distance is tripled, so this new distance now it is 3d, because distance, the initial distance has increased by 3 times. So new distance is 3d. So the new force F3 will be equal to G m1 m2 divided by 3d whole square. So now if you calculate this, this will be equal to G m1 m2 divided by 3 square is 9, d square will be there. So 9d square. So this you can consider as F1. So this can be written as F1 divided by 9. So here force is, the new force is reducing by 9 times. Here if distance is tripled, so if distance is tripled, that means if distance is increased by 3 times, then force is reduced by 9 times. So if distance is increased by 3 times, then force is reduced by 9 times, because F3 was equal to F1 divided by 9. So that means the new force will be reduced by 9 times. If distance is doubled, force is reduced by 4 times. If distance is tripled, force is reduced by 9 times. So this is the answer for this particular second question in the sixth question. Now if you consider the third question in this same sixth question, here they are asking if the masses of both objects are doubled, then new mass of first object, so new mass of object 1 can be considered as capital M1 will be equal to 2 times the small m1. Small m1 was the initial mass of this particular first object. Now the mass has got doubled, so the new m1 will be equal to 2 small m1, 2 times the small m1. Now new mass of second object, that is capital M2, will be equal to 2 times small m2. So that means here the mass of both the objects has been increased by 2 times. So that's why the new m1 is equal to 2 into the old small m1. So the capital M2 will be equal to 2 m2. So that means here new force F2 is equal to G capital M1 divided by capital M2 divided by d square. Distance is constant. So now F2 is equal to, in the place of capital M1 you can substitute 2m1. So 2m1 into, in the place of m2 you can substitute this 2 into small m2. So 2 into small m2 divided by d square. So now we are getting F2 as G into 2 into M1 into 2 into M2. That means both the objects' mass has increased by 2 times divided by d square. So 2 into 2 will be 4. So F2 is equal to 4 into G M1 M2 divided by d square. So this can be the first force, that is the old force F1. So F2 is equal to 4 times F1. So that means in third question, if both masses, so if both masses are doubled, if both masses of both objects, both masses of both objects are doubled, then force is increased by 4 times. So the force is increased by 4 times. So by writing the mathematical equation for universal law of gravitation, by considering old force, new force, you can get an idea how force will be affected when mass of the objects are increased or decreased, and whenever the distance between the objects is increased or decreased. So now coming to the seventh question in this particular exercise, here they have asked the importance of universal law of gravitation. So what is the importance of universal law of gravitation? So what is the importance of universal law of gravitation? You can give so many importance. So all of us are situated on this particular earth surface. Why? Because there is gravitational force influence by earth on us. So that's why we are all intact with the Earth's surface. This is one importance of universal law of gravitation. So you can see all the planets are revolving around the sun. So that is also based on universal law of gravitation. All the natural satellites like moon is revolving around Earth, and even other planets have their own natural satellites which are revolving around them. So all these phenomena can be explained by universal law of gravitation. Even the artificial satellites which we have launched to the space, they are also revolving around this Earth. So there also universal law of gravitation is playing an important role. And because universal law of gravitation is acting, Earth is not moving away from the orbit. It is properly revolving in its orbit around the sun, and also moon is not going away from the Earth. It is properly revolving around the Earth. Because of this universal law of gravitation, all these planets which are revolving around the sun and all the natural satellites which are revolving around the planets are properly revolving in their own orbits because of universal law of gravitation. So these are all the importance of universal law of gravitation. This you can explain in your own words for this particular 7th question. So coming to the 8th question, here they are asking what is the acceleration in case of free fall. So what is the acceleration in case of free fall? So whenever there is a free fall happening, then acceleration due to gravity comes into picture. So for example, if you are considering Earth's surface, if you are considering free fall happening on Earth's surface, so if this is Earth's surface, then if free fall of an object is happening on Earth's surface, then acceleration is equal to 9.8 meter per second square, because the acceleration of this particular object which is under free fall is the acceleration due to gravity of that particular planet. Here if we consider Earth as an example, then acceleration of free fall is equal to acceleration due to gravity of Earth, that is equal to 9.8 meter per second square. This is the answer for 8th question. So coming to the 9th question in this particular exercise, here they are asking what do we call the gravitational force between Earth and an object. That is nothing but weight, because gravitational force which is acting on that object means here if an object is kept on Earth's surface, this particular object will be having certain mass and Earth will be having gravitational force on that particular object, and because Earth is pulling this object with its gravitational force, there will be acceleration due to gravity coming into picture. So that means here mass multiplied by acceleration due to gravity gives you the force, will give you the gravitational force that is equal to weight of that particular object. So that means gravitational force of Earth acting on that object depends on the mass of that particular object as well. That is equal to mass times acceleration due to gravity. So that is the gravitational force of Earth on that particular object. So this particular gravitational force F is on this object which has mass m. So this gravitational force of Earth on this object which has mass m is equal to weight of that particular object, that is mass times acceleration due to gravity. So that's why answer for this particular 9th question is weight of that object. So whatever the weight of that object is the gravitational force of Earth on that particular object. So in 10th question there are two friends where the name of one of the friend is Amit. So now if you consider this as Earth, always remember Earth is not perfectly round in shape. So always you should remember Earth is not perfectly round shaped object. So slightly it has been bulged at the equator and poles are little bit near to the center of the Earth. So that means it is almost in this particular shape. So Earth is almost in this particular shape. That means poles are, so if you consider this as North Pole and if you consider this as South Pole, poles are very much near to the center compared to the equator. So if you consider this particular point, then this particular point is far away compared to this particular point. So that means the poles are little bit near to the center of the Earth compared to the places on equator. So if you consider places which is there on equator, and if you calculate the distance from that particular place to the center of the earth, that is greater compared to the distance between poles, that is north pole or south pole. So that means north pole and south pole are little bit near to the center of earth. So if north pole and south pole are little bit near to the center of earth, then acceleration due to gravity at poles will be more compared to the acceleration due to gravity at equator. So here in this 10th question, you should remember acceleration due to gravity of earth near poles. So I'll just write this as G poles is slightly greater than acceleration due to gravity at equator. So always remember this, because earth is not perfectly round shaped object. So acceleration due to gravity at pole is greater than the acceleration due to gravity at equator. Now coming to this particular question here, Amit buys some gold at poles. According to his friend's instruction, he will buy some amount of gold at the poles. So now don't ask me the question how gold shop was constructed at the poles of earth. I don't know about that. If we assume that there is a gold shop in this particular north pole, and in this particular gold shop, if Amit buys some amount of gold, some few grams of gold, and if he brings the same amount of gold near equator, and if he gives the same amount of gold to his friends, will his friend believe how much amount of gold he has brought? So for example, 10 gram of gold at pole, instead of 10 gram, we can consider the weight of gold was 10 Newton at the poles. Will the same gold measure same 10 Newton on equator or not? It will not measure, because weight always depends on acceleration due to gravity. So now at poles, so acceleration due to gravity at pole is more compared to acceleration due to gravity at equator. So compared to acceleration due to gravity of earth near equator, pole will be having more acceleration due to gravity. So that means weight, if you are considering at poles, so weight of same gold, same amount of gold in pole at the poles, if you are measuring, then it will be equal to mass into G pole. Now if you consider weight of the same amount of gold at the equator, then W equator will be equal to, mass will be same because we are considering same amount of gold. So mass M into G equator will be there. So here, since G pole is greater than G equator, hence W equator will be less compared to W pole, because here G pole is greater than G equator. So that's why W pole is greater than W equator. So what do you mean by W? W is the weight of that particular object. So that's why if you weigh the same amount of gold at equator and poles, the weight of gold will be more at poles and weight of the gold will be less in equator. So that's why friend will doubt Amit whether Amit has kept some gold with him. No, Amit has not kept any gold with him. He has bought same amount of gold to equator. Because acceleration due to gravity has reduced at equator, the weight of gold has also got reduced at equator. Amit has not stealed any gold. He has taken the same amount of gold to equator only. But the acceleration due to gravity has decreased in equator, so that's why the weight of gold also little bit decreased. So this you can write in your own words for this particular 10th question. So this is all there in this particular video. The further questions which are there in this particular chapter, in this particular exercise, I will be teaching in my subsequent videos. So till then, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.